Tigadan 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 pam pam tigadan 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 pam pam tigadan 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 pam pam tigadan.
So moving on to our next presentation is Jean-Laurent Philippe, who's the HPC Director for Intel EMEA in the AGX Accelerated Computing Systems and Graphics Group. He's going to be presenting about the Intel Supercompute Strategy. Welcome, Jean-Laurent.
Thanks, Brian. I'm Jean-Laurent Philippe. I'm the Director for HPC at Intel Europe, Middle East, Africa. And I'll talk a little bit today about the supercompute strategy that we have at Intel. As you know, Intel has elevated the HPC domain to a specific group called AXG, which is the Accelerated Computing Systems and Graphics. And under this umbrella of AXG resides one group among others, which is called the Supercompute Group, where we are doing all of what HPC consists of in terms of hardware and software. So Intel doesn't change its plan in terms of the strategy. We are providing ingredients for OEMs and CSPs and others to develop their own platforms. We help with the software enabling and ecosystem enabling, and we base all of this on our new architectures that we are developing, on the technologies that we are developing also in terms of process nodes, in terms of packaging, in terms of memory, in order to respond to the incredibly growing compute demand. And in terms of computing, what we want to do is keep on democratizing the core computing. It started with the PC era, where we started digitizing everything a long time ago, about 4 years ago. Then we went into the era of mobile plus cloud, trying to connect everything and everyone. And then we are getting into the pervasive intelligence era, where we are seeing 100 billion plus edge connected devices, trying to provide help data to the people who want to rely on the data and the information that is available. Intel keeps on basing everything on open standards. With on the hardware side, we are keeping developing our x86 standard. We are bringing the XE GPU architecture and the underlying software environment under one API that is needed to develop code that runs seamlessly across the various architectures. But in terms of increasing the computing needs response, we need to make sure that we provide support for all of the various types of workloads that are needed and that are run by the end users. In the years 2000, there was simulation that was needed. Then we went recently into the simulation of full immersion. We will be getting into the simulation of intelligent avatars and bots. And as time goes, we will certainly go into virtual economies. Those require more and more compute performance, more and more power. And that means that we need to get into additional levels of acceleration. Not all accelerators are needed everywhere. And as we heard Torsten say, there are some compute capabilities that need to be used in the right place, maybe on the edge, maybe somewhere else. But the compute demand is growing. It's driven by AI everywhere, by persistent immersive web, and it's trending to keeping the core computing for all of the needs that we have, and getting into the accelerated computing where all of the gaming media, HPC and AI, which require virtually the same infrastructure, will lead into virtual economies, as I said earlier, into the future. There are a large number of endpoints that are doing core computing. And on the network, there's a lot of needs. And in the data center, we are also getting into huge requirements in terms of performance, in terms of compute demand, and getting to exascale and beyond zetascale is what Intel plans on working on in the coming years. The AXG division is planning to serve a market which will evolve to potentially $150+ billion in 2026. And it includes the visual compute market for gaming, content creation, metaverse. The supercompute group that I talked about earlier will also contribute to it with HPC, AI, and media. And Intel will have a custom compute group that will be providing blockchain type of solutions or ingredients, I would say, that will build specific solutions and helping with supercompute at the edge. I am in the supercompute group, and we see a 23% CAGR reaching $45 billion worth of TAM in 2026. And we hope that our growth in AXG and the supercompute group will help Intel AXG approach a $10 billion revenue in 2026. So that's our marching order. How are we going to go there? As you know, about 85% of the supercomputers, as per the top 500 list, run on Xeon. And we hope that as we launch Sapphire Rapids later this year, more and more will be running on Xeon. But we also know that as we reach another milestone into bytes per flop, we need to break that memory wall that we are hitting. And there will be a version of Sapphire Rapids that will have HBM on the package so that we have a much better bytes per flop capability. We intend to support about 4x the memory bandwidth with HBM compared to the DDR5 memory bandwidth that will be available on the normal Xeon Sapphire Rapids with DDR. As we get into additional acceleration, Intel is bringing to life the XE architecture, which will translate into a Ponte Vecchio HPC AI ingredient later this year. And all of these will be running inside the one API environment that provides all of the tools for developing code and running code on Xeon, Xeon HBM, Ponte Vecchio. And as you know, one API is an open standard, and we know that there are various versions of hardware abstraction layers that will be facilitating the running of one API code on NVIDIA GPUs, on ARM CPUs, and beyond. So that's a very, very good path to take to develop code that will be portable across not only Intel CPUs and GPUs, but also across the various CPUs and GPUs from the whole ecosystem. A little bit of data about the Sapphire Rapids and the Ponte Vecchio solutions that will be coming this year. Sapphire Rapids will come in a little bit later this year, and Sapphire Rapids HBM will be in production in the second half of 2022. We are expecting with Sapphire Rapids and Sapphire Rapids HBM about 2.8 times the performance on various applications compared to the previous generation of Xeon Ice Lake. With Ponte Vecchio, it is on track for the Aurora supercomputer in the US that has been announced to be above 2 exaflops peak performance. And we are expecting Ponte Vecchio to be up to 2.6x the performance over the best GPU solutions in the market today. And as I said, developing code for those ingredients will be done with the open solution called One API. As we get into the following years, and especially 2023, then there will be next generations of Xeon, there will be next generations of the GPUs, and all of these will be also taking advantage of the development of the codes done under One API. So this is very good and very important to have that and getting it working. As we get into 2024, Intel has announced very recently a new code name, an XPU, which will be called Falcon Shores, and that will be using a mix of x86 cores as well as GPU cores from the Xe microarchitecture. In the x86 core, we have already announced that we will have P cores, the performance cores, and we will have the E cores, the efficient cores. There are already some versions of P cores and E cores running in the client CPUs and GPUs from Intel, and there will be some versions of it and of those at a various level of integration that will be in Falcon Shores announced for 2024. All this requires that Intel keeps on building upon its very good IDM capabilities with, as you can see here, all of the processes that we have announced, Intel 7, 4, 3, 20, and 18A getting into 22, 23, 24, with various innovative packaging solutions with Foveros, EMIB, various types of memory, DDR, HBM, still working a lot on the interconnect for facilitating I/O and the various architectures that we are supporting. So we need to keep on working on our very large world-class IP portfolio. And as I said, we have the Xe architecture, which includes from the ARC for the discrete client and gaming solutions up to the HPC solutions. So they are getting into our portfolio. And in terms of memory, they are bringing a new technologies for memory. We are calling it Rambo. We are also bringing the CXL, the Compute Express Link, as well as the Xe Link between the different GPU ingredients. And that will be helping our strategy to get towards a much more effective set of solutions with various levels of accelerations. All this is built upon our IDM strategy, which is moving into 2.0 with much more flexibility and agility, because we will rely, of course, on the Intel internal process technologies, but we will be also taking advantage of the various different external solutions, typically from TSMC as needed. So as you can see, there will be a whole lot of evolution that will be done on the hardware side and on the software side. As I said earlier, Intel invests a lot on the software ecosystem enabling, so that there are all of the tools that you are familiar with for the CPU that are also available for the GPU environments, as well as for the FPGAs in turn. But that's the whole global solution that Intel is enabling by providing all of the hardware and software ingredients that are available now and that will be developed even further in the short future. As I said at the beginning, we try to respond to a growing compute demand based on new technology foundation that we are developing and that we have recently announced, as well as an execution engine that we are bringing to a new level of capabilities, so that at the end, we are targeting this revenue of about $10 billion for the HPC group and in 2026, and about $1 billion revenue in 2022. Thank you for listening to me, and thank you for inviting me. If there are some questions, because I can't see them, Brian, please let me know.
Thank you. Thank you, Jean-Laurent. There aren't any questions right now. If there's any questions that do come up, I'm certainly going to pass them to you. But thank you very much for that great Intel overview.